on the science behind one of the most innovative ways to cook at home is who else? Dan Kohler.
That's right.
What did you bring for us today, Dan?
Today we are talking about induction heat. And a lot of people at home have either an electric stove or a gas stove. And more the options that are available to you include induction heat. Now, induction comes straight from the chemistry lab. It's something I said earlier, because there's no open flame here. And in a chemistry lab, if you are running a science experiment and you need to mix some chemicals and get a reaction out of them with some heat, you can't risk having an open flame or even an electrical coil, because combustible chemicals can combust. They can combust. Yeah. So scientists actually developed a way to generate heat simply through magnetism. So that's what's happening here, and I'll show you here. I'll open this one up. You see, inside an induction plate, there's actually no heating element. What we have here is a copper coil. And what happens when you run electricity through a copper coil, you get magnetic waves that start to oscillate up and down off it. So this plate is really nothing more than a piece of glass that sits on top, and those magnetic waves come right through here, and they induce heat in the pan. Normally what we have with a regular stove is called conduction, because it's passing heat through something else, either through the flame of a gas stove or through the electrical coil. There's a sort of an intermediary step. But induction is sort of, we use the word for birth, right? When you induce birth, you are causing birth. Well, when you induce heat here, you are causing heat actually in the pan. You are causing the pan to generate its own heat.
Only the pan.
Only
not
the pan.
I have a friend who redid her oven like this because of her kids.
See, this is the thing I love about it. It's so safe to have around the house because the cooktop itself actually will not heat up. What's heating up is the pan here. And the way that happens, when those magnetic waves come up through here, you see iron and steel are very resistant to electricity. So can everybody do this for me real quick? You'll see in just a matter of seconds right now, your hands are heating up, right? Because there's resistance and there's friction. And what happens is basically the same thing. When the magnetic waves go through the pan, they're causing a lot of friction against there because it's actually a very poor conductor. And so the whole pan just heats up.
So you're telling me I could fry an egg in that pan, lift it up, put my hand on it, and not burn it?
Better than that. I'm going to show you. You can fry a pan through cardboard. What other stove could you put cardboard on?
It's not going to catch fire?
Nope.
What? Why not?
And can it be any kind of pan? Like, does it have to be like a cast iron situation like that?
So the thing you've got to make sure of, and that's why I've got this magnet right here, you want to make sure that the things you're using are magnetic. And when you're shopping for pots and pans to use with your induction stove, just take a magnet right off your refrigerator and carry it around.
Like aluminum pots, no.
Aluminum pots and pans are not going to be great, but you can get something very simple like this was 25 bucks. This is a steel adapter. All you have to do is slide it under your aluminum. If you don't want to swap out your pans, then you have a way to
Nothing
use
bad will happen, it just won't heat up.
Right. Now you can see there's cardboard here. It makes no sense. You couldn't do this on a gas stove. You couldn't do this on an electric stove.
Look at that. Wow.
The eggs are already cooking.
Does it cut the cooking time in half too?
It cuts the cooking time way down. You can actually boil water in about 50% of the time here. And you'll see, look, there's no damage done to this at all.
And it's about my favorite way.
Put his hand on it.
My favorite way to cook is to put cardboard under all of my
it's the best way to cook, really. I would never cook without cardboard.
Wait a minute, he just put his hand on that.
Right.
Because it's not. That's why it's so safe. Because he's not anti-magnetic or whatever you're saying.
He's not man of steel.
I don't understand the difference. Is that a negative and that's a negative? Am I making sense?
You're not really.
Magnets. No. Is it one? You know, you put a magnet together and they don't go.
I do know what's happening.
And that sticks?
That's not. So we're not talking about polarity here.
Okay. Yeah. That's my question.
Yeah. Okay. So this magnetic current actually causes an electrical current, which is a little bit different than discussing polarity.
But that's metal now you have on there.
So now this is another. I just want to show you one more way. You saw me put my hand on here, but you can actually prove that. See. Here, so I've got a pan here, and it's going to heat up very quickly. You asked about how quickly this is. You'll see it start to smoke very soon. You can fry an egg on one half of a pan, while on the other half, right on the cooktop,
it doesn't do anything.
that won't cook, and this egg will cook. So that's how safe these are to have around. And
Mark, it doesn't. I'm a little bit. So it's like a magnet, but it's not a magnet. It doesn't connect.
When you run electricity through this copper coil, that generates a magnetic field.
So then the pan won't. How does the pan not stick to it?
The pan, those magnetic fields just run through the pan. It's not about getting the pan to stick to here. It's actually about generating heat inside the pan through that resistance. Now, the thing that we were talking about earlier about safety, if you've got kids in the house, this goes on for all you crafters too, right? If you've got a burner in your craft room and you either want to melt wax or any of the materials that you're using to press something, this is the safest burner to have on hand. You can see I just used this a Friday night. I'm putting my hands on it right now.
Is these
and
really expensive? Ooh, sorry.
they're actually not that expensive anymore. You can get a burner like this at home for sort of like $30 to $50. Now you can get an entire range too. They used to be
So
way expensive.
do they make a full?
They do make full ranges now. Those are a little more pricey, but to get a burner like
If
this,
you lived
is
in
so
an
easy.
apartment, you could
This is
just
the easiest thing to do.
Why
How much money
isn't
does
this?
that save you energy-wise?
All right, so this is the most amazing thing to me. The amount of energy that actually reaches your food with an induction burner is about 90%. On a gas stove, you're only getting about 40 to 50% of the heat generated reaches your food. So you use way less energy. Your electrical bill goes down. This is the most efficient way to cook.
But why aren't they everywhere? Why? Like, there must be a reason why these aren't in every kitchen instead of an electric stove.
I will
Why?
say there's a couple reasons. For a long time, it was price. It's not price anymore, but I do think there's something psychological that we have when we get in the kitchen. We like to see a flame, and I'm not going to argue that. There's something that's real about flame. I think we're still getting used to using science to cook.
But when I cook, if I cook on electric, it seems to take a while. Like if I want to bring it to a boil and back it down a little bit, a flame, you can.
This is the
I
most
hate electric.
precise thing. You see,
Really?
this is even more precise than electric. You can hit that simmer perfectly and just leave it there.
Okay, and then one other thing, because it's steel on steel, Superman could burn his hand on that, couldn't he?
Why don't you go?
But I think that this is exactly how Superman cooks his food.
This is the man of steel. He puts his hand there. Oh, see, I burnt myself. See, that's right. See,
If you burn yourself,
right.
you're weaker
like
than
you
this.
always
egg.
bring the package to
Fascinating. For
Superman.
more information, go to renegadekitchen.com.
Oh my God, I want one of these.
We need one for the conference room.
This one's mine, and the one that we